Hello, this is Ryan Womack. I am data librarian at Rutgers University, and this is a screencast version of a workshop originally delivered at the IASSIST annual conference in Minneapolis in June of 2015, and it's on hands-on big data. So let's go ahead and get started. The organization of this workshop is I'm providing a part 0 that talks about a few of the setup issues and considerations if you're trying this at home. Uh, and so if you need setup help, you can go back and look at part 0. This is part 1, which is pretty much all slides where we're going to just introduce big data and what we're talking about in the workshop. After this session, we'll start to get into Hadoop, and then we'll start to get into actual the hands-on part. But part 1 is just an intro. So I'd like to set the stage just by talking about what the workshop is and what it isn't. I hope it's going to be fun for you. I hope it's going to be an enjoyable workshop. And it's introductory. We're introducing big data, what it is, the landscape, talking about some of the major technologies, doing a little bit of dipping in a real environment to give you a feel for it and let you see some of the technologies at work. But it is not a complete guide to big data. We're not going to have time to go very far. It is not an in-depth programming tutorial. We'll show some examples of code in different environments, but we're not going to talk about the syntax or things like that. You're not going to be able to just run through this workshop and get instant big data expertise. And I'm going to touch on a couple of theoretical issues, but it's not thorough in that respect either. It's an introduction. But that's being said, I hope that you will gain from this workshop exposure to a wide range of big data packages, exposure to a sampling of tools and methods. From that, get a little bit of a sense of the power and potential of big data work and also the limitations. And I try throughout to provide you with pathways for further learning so that this workshop will hopefully help you decide which direction you want to go in and dive in and learn more, which directions are not for you, and so you can decide that and follow up with the links in the slides. Another way to think about what we're going to learn in this series of videos is in jargon or lingo, and we're going to touch on all of these software packages, concepts in one way or another. Hadoop, MapReduce, Pig Latin, which you probably know at least one version of. We're going to talk about another one that you may not know yet. Spark, Flume, Ambari, Cloudera, Tessera, EC2, Azure. So if those things are all new to you, we'll also talk about some other things like Trelliscope and the lasso and SVD techniques. So if you know all these things already, this workshop is probably not for you. If not, stay tuned and you will be at least get some familiarity and be able to keep up with some of the lingo in the big data area. Again, in terms of setup, I put these slides and all of the code and scripts that we're going to be working with at my GitHub site, github.com/ryandata/bigdata is the folder that has these materials. So if you go there, you'll see a few scripts, a few sample files, and also the PDF. Now, just a note about the PDF, when you click on it, it's going to try to pull it up in a viewer on screen for within GitHub. But if you want to download it, you click on the raw button, and then you can get the full PDF with working links. The links won't work unless you download the full PDF. So once again, GitHub, Ryan Data, to find all the materials. That should also be linked in the YouTube description. So I'm going to give you several demos along the way. that should be working scripts. What I'm not going to do is go through the details of doing this in different operating systems. My main setup here is a Linux setup, and we're going to run things out of the shell or the command line or the terminal for the most part to get things going. And our web interfaces should look the same on Linux or Windows or Mac, but I'm assuming that you can get to a command line. Now, I'm going to talk about that a little bit in the setup description in session 0, so you may want to go back and take a look at that. But I'm hoping you're familiar enough with your OS to kind of navigate around. Okay, a little bit more background about me. I am a data librarian. I work with helping people find data, purchasing data, teaching some introductory software workshops on how to use statistical software to access data. So I'm coming at it from that perspective, not a computer science perspective. I've heard about big data as a buzzword for a long time and kind of wanted to go behind that and find out what does it really mean to work with big data. So I'm new to it, and I hope I can bring you along that journey with me. And if I can do it, you can too. That's one positive aspect of that. Some of you may find this a little bit too basic for you, but even so, I hope there may be some bits that you can dip into and get something along the way. And again, my goal is really to get you started and enable learning beyond this workshop. So I hope that this will be a jumping off point and that many of you will go beyond where I am in terms of big data expertise. Okay, so now let's talk about what is big data. Okay, it's a big buzzword. It's shows up in lots of media articles. Certainly a hot topic. It's also a concept that describes data of a certain size and scale, and we're going to get a little further into that in a second. But also think about it as a set of practices where not just the data itself is big, but the environment that the data lives in, the computing environment, the programming environment, the ways that people handle that data, all form part of what we call big data in quotes. And it's an ecosystem. It is an evolving ecosystem, one where the best tools and the best software, best techniques evolve pretty rapidly. And this workshop is at one snapshot in time in June 2015. If you come back to this sometime later, you'll find things have changed and there are going to be things that need to be adapted as well. But I'm not planning to update this video series on a real frequent basis, so it will probably stay as a 2015 video for some time. Okay, so I've given some links in the presentation just to some Google searches. I didn't want to get into image copyright issues, so these are just sort of spontaneously jumping in, and let's see what Google has to say about what does big data look like. Well, you'll see images like this, a big funnel of binary digits, some sort of landscapes of data, some little interactive widgets, sort of meshing in complexity. This is probably what many of you have in the back of your mind when you think of big data. But big data in reality is also something like this, as described in this article, which is an interesting descriptive article in itself. But big data as it exists out in the computing world is happening in places like this, racks and racks of computers networked together, forming clusters where the data can be accessed and processed. And so it has a physical reality like that. It's something beyond an ethereal flow of digits. and also to illustrate the ecosystem of big data, we have things like this, the big data landscape, and there are many companies and hardware, software, consulting companies providing all different kinds of solutions in this space to solve different problems. And as we're going to see just from our little exploration, it gets complex pretty fast, and you can understand why there's a need for many companies to operate here. And we're just going to really touch on a few of them, but a graphic like this kind of illustrates it's a big landscape. Again, something to keep in the back of your mind. Okay, some of you may have seen this before, but I want to make sure everyone has seen this. So when you hear talks about big data is typically defined by 3 V's, at least 3 V's. Velocity, high-speed data. Second, variety, lots of different kinds of data. 3, volume, a big data flow. And some people add a 4th. Sometimes they add veracity. Sometimes they add value. So is the data reliable? Can it be used to inform decisions and actually help an organization or an individual in a practical way? So if we look at these 4 V's, this is a link to an IBM graphic, which is quite good actually. When we think about volume, and we've heard it a million times, the volume of data is growing, constantly growing in a somewhat exponential fashion, and we're evolving to keep up with that. But big data also means when we have all these different streams of data, we have to somehow connect them into something meaningful. So can video be linked with tweets, can be linked with search information, can be linked with some kind of individual data. The data is coming in fast, constantly. We have to both store it and process it on the fly, develop special techniques for that. It's not going to stand still long enough for us to sit down and carefully caress it into a nice form. And veracity, of course, when the data is flowing in from many different sources, we have to be quite careful about the reliability of those sources, and our techniques. Are our techniques for knitting the data together reliable and verifiable in themselves? So those are the V's. We can also say that in the computing sense, big data is data that is too big for a single computing instance. We have to start sharing it out over multiple machines, and really big data over many machines. This is a pure computing challenge. There's also the personal definition of big data, that big data is any data bigger than what you personally know what to do with it. If it's bigger than Excel will open and you've never done anything like that before, well, that is big data the first time you encounter it, even if it could be handled on a single machine with a different technique. You're starting to press your own boundaries. And I would argue that big data it's again a shifting thing. It's always evolving as our skills and powers of computing get better. What qualifies as big data is bigger, but it's some kind of combination of the computing definition and the personal definition. We have to develop new methods and new physical hardware to work with this. Okay, so the data is big. We've defined somewhat what it means to be big. How do we deal with that? Well, one way to deal with it is to just throw more power at it, more memory, more processors, more disk space. And this is a a traditional approach. This has actually been going on for a while. Now, the scale at which it's going on now is much larger than ever before, but we're talking here about traditional high-performance computing, parallel computing, really big databases that have new methods to handle this. But actually, this is not what this workshop is about. First of all, these kind of techniques tend to be expensive. They're kind of centralized, and they're good at certain kinds of problems. Well-structured data, well-specified models, things where we have a better control over the data elements. This is not typically what people talk about when they talk about big data in the media. Big data in the media, it refers to the big data that is being generated by web scale activity, where millions of different users are all using something at the same time, generating search logs, records of their activity, browsing records, and all this stuff, comment logs, things like that. All this stuff is being stored on many different locations that may all be linked together, but it's a kind of a decentralized network. And this is what the big internet companies like Facebook, Yahoo, Google have built up their technologies to deal with. They were the first to really experience it at a big scale like that. But the same issues apply to sensor data that's coming in from many different locations to form a part of the scientific record. That's also dispersed, unstructured, high volume big data in this sense. So we're going to talk more about this type of data, and again, just to set the stage, this is a link to an XKCD cartoon. We're thinking about things that happen out there in the cloud, and we don't really know what that cloud is. We hope that it's not a single cord leading to a little computer like this that could be tripped over and there goes everything on the cloud. We hope it's not like that, but we don't know too much about it. There's a level of remove that we have from what actually happens on the cloud. So the hands-on part of this will, I hope, give those of you who are new to this a bit of a feel for that. I throw in a link here also to how big data relates to data science. This is a nice little graph, if you've never seen that before, a visual Venn diagram explanation of what is data science. Well, data science is a kind of a mixture of several different domains of knowledge that have sometimes been separate in the past. And this post is actually pretty good at linking that concept of data science and to how it applies to big data itself. So data warehousing, data analytics, and things that we would do with data science. So that's just thrown in for a bit more background. Okay, so at this point, the next section is going to deal with Hadoop, which is going to be one of our core technologies for much of the session. So I'm going to break here, come back in the next section with more on Hadoop.